Hello and welcome to Chapter 7. Most of Chapter 7 is going to be about something new, likely for you, unless you happen to have studied logarithms at some point uh, in your life, but that's what it's going to be mostly about. And we actually don't get into logs, I don't think, start till section 7.3. And logs are sort of like the opposite of exponentials. It's like the inverse function, I guess. From last chapter, we talked about inverses. And so we're going to do exponential stuff first and then get into logs. And if you forgot what exponential is, then we're going to go over it a bunch in this lesson. There is a note sheet that's associated with this. Again, if you don't have the note sheet, you can just write it down in your notebook. So our goal today is to talk about exponential growth and decay, something that you likely learned in Algebra 1. All right, so this hopefully is a review from Algebra 1 before getting to the new stuff, log stuff. Okay, so the basics of exponentials, all right? So there's a lot of different types of functions. There's linear ones, all right, where it just kind of goes up by the same amount. So like if you had a Twitter account, this is all about Twitter and followers, and so you had, sorry, it's weeks, I guess, in this case, weeks and your followers. So if you were born like Mr. Westpatal, maybe the first week you just had 5 followers, and then as the weeks go up by 1, you just gain, say, maybe 3 more followers or something like that. That's a linear one. And what an exponential function is, so linear is like adding the same amount each time, like plus 3, plus 3, plus 3. And what exponential is, if we do weeks and followers, it creates like a multiply pattern. So here was an add 3 pattern that was linear. And so in this case, let's see, we have, I guess we could say week 1, we have 4 followers, right? And then they double each week. So week 2, you would have 8. Week 3, you would have 16. Week 4, you would have 32. So you can see these go up much, much faster than linear, right? Linear is just adding or subtracting the same amount, and an exponential, you're going to be multiplying by a value. It's just going to go up or down, I guess, really quick, right? So that's just roughly what it is. And certain things are like that in life, like certain videos just explode on the internet, become viral videos, and their views might look something like this, where exponential graphs, right? They start off kind of slowly and then go up like this. And certainly there's videos and stuff like that from the internet, Gangnam Style or some Justin Bieber video or something like that. Starts off slow, but then goes up like crazy. Okay, so I want to talk about the exponentials. What do they look like as tables, as equations, and as graphs, right? So you could think of functions in all these different ways. Um, And so as a table, or they make like a multiply pattern. So this first one would be, so these are like kind of yes or no, are they exponential? And this one is yes, and it's because it's multiplied by 2. So it's a times 2 pattern, so that's exponential. So pause the video and see if you can figure out these other ones, which other ones are exponential. All right, certainly this second one with f of x is, because as these go up by 1, these are multiplying by 5. Okay, so that's definitely going to be exponential. And this next one is no. So this goes plus 1, plus 2, plus 3, which is a pattern, but it's not an exponential. Exponential, you're multiplying by the same amount. Last one is yes. It seems like it's divide pattern, which it is. I mean, it's dividing 2, but we could also think of it as multiplying by half, right? So because you're multiplying by the same number each time, that one is exponential. Okay, so as far as what does their functions look like, right? So we want to start to write the function. And so basically they have 2 parts. They have like a starting number and then the number that you multiply by each time. Okay, so basically I think they're gonna, later it's gonna be A and BX. So A is like your starting number and B is the value you multiply by each time. So for this first one, we could say that like the relationship between x and f of x is -1. That's our starting thing, is the 0 term in the table, times 5x times. So that each time x goes up by 1, you have one more exponent, one higher exponent, so you're multiplying by 5 one additional time. Right, and so this last one, this bacteria one, you would start with 128, that's your 0 term, right? And we'd write it as times, instead of divide by 2, we're going to write it as times 1/2 x times. So really, when you write the equation, or function, you just need the two things, the starting number and then the number you multiply by each time. All right, and that actually leads into our next slide, is what do they look like as equations? And the answer to that is the exponent, the exponent is a variable, right? So instead of, I think in earlier chapters, like chapter 5, we did polynomials, and there it was like x cubed plus x squared minus 4x or something. There your exponents were numbers. In the exponential world, the exponent is a variable. Okay, so we should probably, just to make this complete, I should probably put this on here. Sorry, I should have said this before. So what do they look like in table world? So they exponential functions make a multiply or divide pattern in the table. All right, so that's what they look like as table. And if we do a similar thing for the equations, so in the equation, sorry, my computer is freaking out here. In the equation world, exponential functions have exponents that are variables. Okay, so based on the definition, go through 1, 2, 3, 4. Which of these would be exponential? Pause the video, give it a shot. Right, and if you said that the exponentials were 1 and 4, ask your parents for an extra cookie at dinner tonight, because that is correct. The exponents there are variables, right? And on number 2, the exponent is 1. That's a number, so that doesn't count. Here, exponent is 5. So those are polynomials, not exponentials. Okay. So what do they look like as graph world? All right. And there's really two types of exponentials. There's called growth, and then there's decay. So we're going to draw a picture of two of them here. So how growth works is you start on a number, right? That's like the 0 term in our table. And then you kind of grow slowly at first, and then boom, it skyrockets. Okay, so there are, again, like think of the videos on YouTube, the number of times it's viewed or the number of times something is liked. It can start off slow and then grow really, really fast. Okay, and as far as decay, that's going to start off as a big number and then drop quickly at first and then kind of slowly curve off like that. So it's kind of the reverse shape of this. So like that bacteria dropped really fast at first, but then it kind of slowly curved off after that. Okay, and if you want to draw the other side of it, sometimes these are real life things, so we don't draw into the negative, but if you want to draw into the negative part here, that's what it would look like on the other side. Sorry, this one got a little messed up. My computer is apparently, this is too much for my computer today. Okay. So real quick, one more just for you on your note sheet. Which one of these would be, which one, maybe there's more than one, which ones are exponential? Okay, so again, you can win another cookie for tonight if you said that one. It starts off slow and then goes up from there. This one would be linear, and this is for an extra bonus glass of milk with your cookies. This one is an x squared. Wow, my computer cannot handle this. Yeah, this one is x squared or quadratic. That's the parabola shape. Okay, so we talked about there's either growth or decay ones. So you have to figure out which one of these is growth and which one is decay and why. So pause the video and give it a shot. Okay, so the one on the right is going to be an example of growth. And the reason is this number, we're starting at 100 and we're multiplying by 3. And so if this number is greater than 1, then it's going to grow. So basically, whatever you want to call that, the base number, if that's greater than 1, you're going to grow. Right, versus the other one, we're going to start at 50 and we're going to multiply by 0.5, so it's going to get smaller. And that's called decay. Okay, and that'll happen when the b value is between 0 and 1. So bigger than 0, but less than. 1. Okay, as far as like graphing them, there's probably not going to be a lot to know now. I mean, if it says it in homework, just sketch it. So like this one would start at 100, the y-intercept, and then it would go up real fast as you multiply by 3, right? Versus the second one's going to be decay, starting at 50 and then getting cut in half each time. So after x is 1, you're already at 25, right? Until you get cut a half each time, it looks something like that. Those are pretty poor drawings, but if they ask you to do it in homework, just sketch a picture. Okay, so determine if it's growth or decay, and then what is the y-intercept starting point? Pause the video. Okay, so this one's going to be decay, and our y-intercept, our starting point would be the 12. So we're going to start at 12 and multiply by less than 1 so it decays. This one is going to be growth. We're going to start at a quarter and then double it, right? So our y-intercept would be 25 cents or a quarter, 0.25. All right, and then the final thing we're going to do today is we're going to start to talk about it in like savings accounts and interest accounts. And so this one would be an example of growth. So if you get paid extra interest, like 5% interest, you're going to grow. So you're going to start with 1,000 and then gain 5% each year. So that's going to be an example of growth. And that's the last type of problem we have for today's lesson. All right, and so this formula, for sure, I would jot this down, right, along with the explanations over here. All right, so basically, this says the amount after a given number of years or minutes or whatever is equal to the starting amount and then 100% plus the extra rate as a decimal, and t is the number of years. Okay, and amount, A of t just means the amount after so much time. And definitely get this formula copied down before going on. Okay, so you said say you get like a $500 account or something from grandparents or something, and you're gonna put it, you're a freshman, you're gonna put it in an account that gains 3.5% interest a year. And how much will you have after 4 years? Okay, pause the video and see if you can fill in the different parts here. All right, so the little formula is 500 for A is the starting amount, and then 1 plus R. So when you do the R part, you got to move the decimal twice. So you're going to go zoop, zoop, move it over. And so that is 0.035. All right, and then 4 years up there is the exponent. So really we're looking for the amount after 4 years. All right, and so 1 plus that is 1.035 to the 4th power, right? And then it's just a matter of typing that into your calculator, which I can show you real quick here if you've never done it before. I'm going to go into y equals screen and type 500, and then the 1.035, and I'm going to put that in parentheses because you want to raise all of that to the 4th power or whatever. And then I'm going to hit, what am I doing? Actually, I don't even need to do it in here. What the heck? Not even in y equals 500, 1.035 raised to the 4th. So 573.76. Okay, and then kind of a reverse question of this is like, how long will it take you to get 650? Right, so this is actually where I was getting ahead of myself. This is where you're going to use the y equals on your calculator. So on this one, we want an amount of 650. And then this part looks the same, at least at the start. 500, 1.035, the interest is the same. But now we're going to put x or t as a variable because we don't know how long it's going to take. Right, how long will it take? So we don't know the time. Right, so this is actually where you can use the y equals and type this in. So I'm going to go back to my calculator. I'm going to go to y equals. And then instead of the 4, I'm going to put in x because we don't know how long it's going to take. So I'm just going to make that x and then go second table. And we can see how long it takes to get to the amount we want. So to get to 650, it would take 8 years.